All right. Hi, everyone. Hello. Hi. So I'm gonna draw on the board just for a brief while, and then we'll start coding again. So what I wanted to talk about is what we were basically talking about last time when we were talking about alternatives of storing blocks of structure, right? And those are kind of like the options, right? So you could say I have a bunch of structures and they all just store the name, right? So like Mike, whatever is my GPA of the fly, and then whatever Bob, four, and Alex is four, and so on. Incidentally, there was an error in the computation of some of the marks for ESC190 that has now been fixed for everyone except for the people who did not write the exam. For those people, this will be fixed. Hopefully today, I sent in the corrections. So if you check a form, you might be pleasantly surprised by what you see. Okay, so that's one option. So another option is to say, I'm not going to store the strings themselves. What I'm going to store is the addresses where the strings are stored, right? So I might say, I still have basically the same kind of blocks, but what this block is going to store is maybe this is 1024 and this is 2024. I'm making those numbers up a little bit. 3024 4000, and then those are still numbered. And then over here, what's going to happen is somewhere else. This, of course, is also in the memory table, but somewhere else in the memory table, I have my strings that represents the letter, represent letters, right? So, for example, you know, at 1024, we'll have the mic. So 1024 would be over here, and this would be like M-I-K-E, and then an L. And then somewhere here, so at 324, we'll store Alice. So this would be 324. And then over here, we'll have A. Those are all in single quotes, just to indicate that they are characters. And so on, right? So the information here, it's everything is stored within a single block. Here, what we're storing is just the address where the name is stored. Make sense? So we can actually go one further and say, I want to store those kinds of things, but I don't want to store them, all the information in the block. So I want it, you know, uniform, but I don't want to, I just want to store a pointer in the block. I could do that as well, right? So I could have something like 5,000. And then this is like whatever, 64,000 and so on. And then in here, what you'll have is at address 5,000, you'll store Mike and 3.95. Right? So over here, it's going to be whatever, like 5,000. And then there's going to be a bunch of addresses here. And it'll start maybe by storing M, and then I, and so on. And then somewhere over here, it stores 3.95. not my real GPA. So okay, not for undergrad, not both. In grad school, I did have 4.0. But it's easier in grad school. So it is right. Like people are less neat. So like once they let you in, they're stuck with you. So, not a joke. It's like a completely correct representation of reality. Actually, if you get there, you'll find. So okay, so that's like that, right? And there's kind of upsides and downsides to each. So one upside to doing things like this is the block itself is just a bunch of addresses. So you need less memory in order to store, in a way, the block itself. Of course, like here, you'll have to go, like once you go here, you have to spend all those resources storing everything. Now, it might be that you don't have all those inputs initially, and you don't need to allocate all of them until you actually decide, okay, I need to store a student here, and now I'll allocate whatever I need to with malloc, and then I'll store the data. So you won't save eventually if you need to store 100 students. In a way, kind of the first way is the best one because you just store the information and nothing else. Anything else, if you indirectly say, I'll just store the address for now, and then I'll store the information, well, now you're storing both the addresses and the information. Right? So we've left out one option, which you do this kind of thing, but in here, instead of storing the strings, you are storing addresses of strings. Right? So for completeness, let's do that as well. Maybe over here. So that's, let's say, 7,000, and that's 8,000. So I don't want to, so I'm just going to do Mike and Bob. And then what you're going to say is at 7,000, you have the address of a name. Maybe that's 10,000. And then over here, you'll also have the GPA, so you'll have like 3.95. And then elsewhere in this memory table, you'll also have a cell 10,000, and that is where you'll store money. Make sense? So those are basically just conceptually the options. You have a table. How do you store a bunch of students who have a name and a GPA in this table? So what I want to do now is just go to VS Code and code those four options out. All right. It does not show different table. All right. So we are over here. So I'll save it as student versions. Okay. So option one is store everything inside the struct. So that would look like this. So I have to specify that I'm storing 50 characters inside the struct. So if it's not a pointer, if it's an actual array, that'll go right there. This is like saying that I have a car named 0 and car named 1 and so on up to car 49. It's the same. Those variables all go there. It's just more convenient if I have it as an array. And here we have double GPA, and we'll do the type def thing. So, okay. So another option would be to store a pointer to the name rather than the name itself, right? So inside the struct, okay. How many people managed to install Copilot? Okay, so for the benefit of the people who haven't, I'm still kind of like typing along with the gray text if the text is correct. But I really do suggest that you do install Copilot because, you know, it's convenient for lectures. And it's usually correct, although it just lied. If you noticed, it said something that wasn't true. Okay. So how is this different? Well, in here, we're not really storing the name. What we're storing is the address where the name is stored. So that means that student 2 takes up less space than student 1. So more efficient is arguable, but takes up more space, less space than storing car name 50. Right? Makes sense? Now, of course, at the end of the day, if you're storing 100 students, well, you have to store their names. So it might be that this becomes less efficient because you need to store both the names and also you need to remember where to put the names. It might be that this is less efficient because here you need to pre-specify that the length of the names is 50. So if most of your names are a lot shorter than 50, you're not using most of the space in those arrays at all. So you can have that. And at this point, we can have different ways of storing the blocks, right? So you can have an array of student ones. And that would be just like that. Say 150, right? And this corresponds to just 150 cells store the entirety of the information about the student in the cell, right? So you have 150 of those things. You can have a malloc block of student ones. So that would be like this. So that's not different, except instead, student one, except instead of saying, kind of coding in, I need 150 and not being able to return the block as one, I'm mallocing it. So the advantages are unlike S1, can return S1 block because the address S1 block is valid until we explicitly free it. Right, so you cannot return, you can return S1, it's just if you try to use it, it'll crash, most likely. And that's because S1, the array, if you declare it as a local variable, if you return it, you're done. So you return a number where the array used to be stored, but it doesn't mean that you're allowed to access it at that point. Okay, so you can have an array of student twos. Similarly, now, just because you have an array of student twos does not mean that you get to start accessing it, right? So you cannot say right now, and that would be because s2 0.name is not a valid address. It's not a valid address because we never said what it is, right? So you just initialize this array of just random data. So name would have some value. It would usually not be a valid address. So you try to do this, it will just crash. However, that is fine. Not because it's a valid address. It's not the address. And that's just because GPA has some value. And it will be printed. Right? So name also has some value, except name is an address. And if the address is not valid, you cannot go there. On the other hand, GPA is a number. It could be a negative number. It could be whatever, but it's still a number. You can print it. Not a problem. Does that make sense so far? Questions? Yes.
By declaring car start date, I call out not going to get some.
Well, so it could be that you would. So it's some address which is not guaranteed to have any particular value. You could get extremely lucky and or unlucky depending on how you look at it. And it could turn out that name happens to be a number that is also an address of a valid string. It would be a weird coincidence if that were the case, right? So usually it would be just some number. GPA, similarly, it would be some number, but there's no problem with printing it because you're saying whatever GPA is, I'm just printing it. And you'll get whatever it is. Usually it would be 0, but not necessarily. When you're printing something as a string, you're saying this number is not just a number, it's an address. Go to that address and then promise you're allowed to access it, and there is a string there, and you should print it. And that could be a lie. Does that make sense? So you could, maybe that would clarify things. You could say printf LD and then print s20.name. And that will print some, well, garbage is strong, but some arbitrary value. Right? So that is fine because s2.name, you're going to this block, you're getting a value that's stored in name, you can print it, it's fine. The problem is if you start interpreting that value as if it were a valid address, which it's probably not, and trying to go to that address and print stuff at that address, which could cause you to crash. Of course, like whether you crash or not, what you're doing here is you are making C engage in undefined behavior one way or the other, right? So you cannot predict what it will print, whether or not it will crash.
S2.name, we are storing value that's addressed, but that's the arbitrary value.
It won't be literally random and as well, like nothing on the computer is like truly random. It's all there for some reason, but it will not be anything in particular. No. It will be nothing in particular because like you didn't initialize it. So it could, when a variable that's not initialized, its value could be anything. So the way to think about it, and we'll do kind of bit representation later on, is what's computer memory? It's a bunch of ones and zeros. So you're saying when you're allocating an array or allocating a block of memory, you're saying, I'm going to use this block of memory for this purpose. And then when you're saying something like s2 at 0.name, you're saying, go to this block of memory, which I allocated for this purpose, and then interpret the patterns of the bits there as if they were an address. But you didn't set them to anything, so they won't be a valid address. You would just be interpreting things as if they are an address. All right. So, okay. So that's like that. So if we want to use it, there are two ways to go about it, right? So we can say something like s2.0.name is equal to John. Right? So this could be fine. Or we could say, yes, so let's malloc enough space in name. So now set s2 at 0.name to the thing that malloc returns. And now you can set either manually or with strcpy. So most of the time you would do strcpy. So you're saying copy the j into s2.0.name at 0, copy O into s2.0.name at 1, and so on, right? Right, so this is the same as this. All right, so that is fine, and that would work the same way with a block of s2s as well. The difference between the block of s2s that's malloced and an array is this, right? So we can return s1 block to outside the function. We cannot do it with an array, and we can arbitrarily say I want this many. Yeah.
So for both methods, you're allocating the amount of cells in memory that are going to be utilized to store the information inside the structure.
Well, yes, except note that when I'm doing this, I'm not exactly allocating enough space to store the information that they need, right? So I'm allocating enough space to store 150 student twos, but the student 2 is just an address plus a GPA rather than a name plus a GPA. So what I would need to do is either I could do something like this, where I just set the name to a literal, or I also separately need to go and allocate space in order to store the names. Make sense? Yeah.
So like, example, can you like go to each individual letter and change that value?
Which this one?
The second one.
I'm not sure how you're counting which line.
No, like the second example, the second way is that.
Yeah. So this is the same as this.
Okay.
So to be clear, the strcpy is the same. It's like that's literally what strcpy does, right? As it copies things character by character, and the last thing it copies is the null. It's just less, like you wouldn't do it, it's less convenient, but yeah. Right? Yeah.
How come in the first example it says you're not allowed to modify?
Right. That's because this is a const char star, and you're not allowed to modify const char star. So if you try, that is undefined behavior, the program might crash. All right. So, okay. And here, so the question might be, well, like, isn't there a literal here as well? Well, yes, but we're not equating anything to the address of this J. What strcpy does is it takes this J and it copies to J, and then it takes the O and it copies the O, and so on. Make sense? So, all right. So we could say, okay, let me do it the third way. So I want 150 students, but I don't want to store even kind of the small structs, right? So the student 2 is a smaller struct than student 1, even though it might be that that's not a smart decision to do it, but for now, this is smaller. What I could do is I could say, well, I want to store the address of, so that's the example from over here, the address of each student in the block, and that's it. So this would be like this. So the way to think about it, so this is where things get kind of complicated. Well, so far it's been easy, right? So the way to think about it is, okay, we want a block of objects. Each object is a pointer, right? So I want student 2, so I'll name it PS2 block. So what is this? So it's the address of the first element of the block of objects that are of type student 2 star. Right? So I said, I want a bunch of addresses, and each address is an address of a student. An address of a student is of type student 2 star. So an address of that kind of thing must be student 2 star star. So that's why it's a type pointer to pointer. Right? So it's always the case that if you want, for example, a block of student 1s, well, what do? You say, I want a variable that's of type student 1 star. So the address of the first element, the element is of type student 1. So the type of the address is student 1 star. Here, what they said is, I want a block of addresses. So, like, 40 St. George Street, 42 St. George Street, and so on. And then the building themselves are elsewhere, right? So I'm just storing the addresses. So if the objects in there are of type student to star, then it must be that this is of type student to star star. And now I need to malloc it. So cast to student to star star. Malloc. So what do I need? So let's say still 150, and then I say size of student to star. Right? So what's going on here? I'm saying, give me enough space to store 150 objects that are of type student to star. So I want to store 150 addresses. Each address is an address of a student to. Does that make sense? So, okay. So can I use any of that now? Well, absolutely not, right? What I have is 150 empty cells where I could store valid addresses if I wanted to, but I haven't done that. So if I want to actually be able to store a name, what I need to do first is I need to actually allocate space in order to store those students. So let's do that. So I'm going to say PS2 block at I. So this is the ith address in this block of addresses. I want it to now be a valid address of a student 2. So do the stars here make sense? Yes. So here what I did is I malloc 150 cells where in each cell I could store an address of a student 2. So that's why it was 150 times size of student 2 star. And now I'm saying, look at I equals 0. I want to allocate the first student. So I'm going to say, okay, the first address, I'll get it from malloc. What do I want from malloc? I want from malloc an address where I can store an actual student 2. So that's why I tell malloc, give me enough space to store a student 2. But that's not quite enough, because the student 2 itself has an address of the name, and it has a GPA, which we're now finding. So we'll give them a 4.0 GPA to start, just because. So that we're now allowed to do. What's going on with the arrow here? So this is an address, right? So PS2 block is a bunch of addresses. So PS2 block at 0, that's the first address. So we're saying at this address, we have a structure of type student 2. Go and retrieve the GPA from the structure at that address. That's what the arrow does, right? So to review the arrows. So the arrow, if you remember, is just syntactic sugar, right? So if you have student to S2, then you would access S2.GPA, like so. If you have an address of a student 2, so for example, I say student 2 PS2, and that's just address of S2. Then what can I do? I can say PS2 arrow GPA, and that's the way people usually remember it. Like if it's a pointer, then it's got to be an arrow. Really, the reason here is that to access the value, you would say star PSA. And then you can say dot GPA equals 4.0. Right? Really, you're saying go to that address and get me the struct. And then once this is a struct, the right thing is dot GPA. And the arrow is just a shorthand for this. So when the compiler runs, any arrow just gets converted to this. Okay, that's just how it works. Again, like this kind of thing, maybe you don't need to think about every time you write code. I think most people just have this notion, which is like a correct notion, that if it's a pointer, it's got to be an arrow. If it's not a pointer, it's got to be a dot. Yeah.
I'm still not sure what the advantages are.
Well, so the advantage would be that the array itself could be quite small because all you need to store per element is just one address. If you eventually do store all the students, yes, but sometimes the situation might be that you are not sure whether there would be more inputs, but you already allocated a bunch of pointers, but you haven't actually spent the space on storing the students because they don't exist yet. All right. So, okay. So that's like that. Now, that is not enough. Yes. So yeah, so that's what I'm about to do. So the other thing is, yes, kind of if you want to, so there's two ways of going about things. So you could do something like this. So that's again like the same thing that we've done before, or you can do PS2 block name equals John. Also fine, but weird. How do you know it's John? Right? So like if you knew that the name was that ahead of time, then why did you go through the entire exercise of creating the array? Like you already knew the answer. Usually you would not know the answer. You would get it from input or something, in which case this kind of thing on line 70 would just not come up because you don't know that the name is John ahead of time. You might argue, well, like line 68 would not also come up for the same reason. And no, that's not quite the case because here I'm just using strcpy in a generic way. It so happens that I decided to plug in John there, but it could be a variable as well. Right? Or it could be something I got from the input. Does that distinction make sense? So, okay, so the general thing is what we've done is we've allocated space to store addresses of students too. Oh no. Yeah, I'm not sure. My computer got updated on Sunday and yeah, it's been trouble. So what we've done is we've allocated space to store students too. I'm restarting. At that point, we said similar thing is I have a list of students, and each student is like a name in the GPA, right? So like Alice is like 3.9, and then Bob is 3.8. And so on. So in this case, this is kind of stored as a list of lists, which is like not necessarily the best thing, but so let's actually do dictionaries so that it's kind of more similar to what you would expect in practice. So this would be like Alice is, sorry. So name is Alice. And GPA is 3.9. And then the same here. So name is Bob. And poor Bob just has 3.7. And that's a list. So how does that work? Well, exactly as, well, almost I should say exactly as what we've done in C, with the difference that this string is immutable. So this is a const char, right? So we have L is stored at kind of, let's say, at address 10,000. This is 100,000. So at address 10,000, you have L, and then L0 is stored somewhere. So that means that L is at 2,000 at 3,000, something like this. And that means that we have a 2,000, we have a 3,000, and then Alice and Bob and 3.9 and 3.7 are also each stored at their own address, right? So for example, Alice is stored, so those are all arbitrary. By the way, I hear people are like started murmuring. It's either because people already know all the Python they need to know, and therefore not listening, or they think they need to know the Python they need to know because they think Python is not on the midterm, which is not guaranteed to be the case. So Alice is stored at, so like anything that's in this class is potentially, of course, on the midterm. So Alice is stored at 5,000, and let's say 3.9 is stored at 6,000. So this would be, again, this is like slightly simplified, but like name is at 5,000 and GPA is at 6,000. Right? So name and GPA would also actually be need to store somewhere, but like that's as far as we go here, right? So this is the same kind of structure. Everything in Python is stored as an address. And that's what we tried to do in the last code, where we said, in the last piece of code, I should say, where we said, okay, like we have an address of a block, and then the block is itself all addresses. And then inside each element of the block, we also store an address. And that's exactly what Python does, but more so. So in C, there is a mix, right? So we don't store the GPA as an address. The GPA is an actual number. In Python, anything that's inside a nested structure would be stored as an address. So analogously to what's going on here. Make sense? Yeah.
So the advantage to doing the last way is if we didn't know how many students we were having, then it's like less memory.
Yeah. So like here, yeah, like that would be the address.
Also easier to like reallocate.
Does it look easy? So it's easier to reallocate memory for, you know, the base array, but then you also need to allocate stuff for new. So I would not say that it's on balance easier. And kind of the reason we're doing this is like well, like one, I kind of want to walk up and we almost had done to, okay, like this is the equivalent to what Python does, but in C. And also like you'll see variations on all of that, right? So it's true that you might focus on like one way of doing things and there's multiple ways and there are trade-offs, but there are not like huge trade-offs. But you know, you can't just focus on like here's the one way to do things, and then you see someone else's code and they did it the other way, right? Anyway, so that's that. We'll do a few more examples from the pointers exercises as well. But the idea with the exercises is there's a lot of them. So just like with like high school algebra, you just do the exercises, you get used to this kind of stuff. All right, I'll see you tomorrow. Bye. Thanks.